All right, folks, welcome to the first lesson of Calculus BC. In the first lesson, really, there's nothing too big. The biggest thing that we're going to be talking about here is just remembering that a lot of calculus is how we can make things, rewrite them in a way such that it makes them easier to work with. That's a lot of what our goal is. So this first one is really just about u substitution. That's kind of our deal, and other integration rules that we learned in AB Calculus. So with this first problem here, I'm going to go through 3 problems and that's going to be it. Pretty short for our first lesson. But with this first one, so looking at this, I see a square root, right? And it would be nice if we could do u substitution with that part. But if I do that, like let's try it. Let u be 4 minus x squared, then du would be negative 2x dx. The issue with this is that I don't have this x times. I do with just this part, but this plus 3 is kind of throwing me off. So let's rewrite this thing such that maybe I can use this u substitution. So I'm going to leave it there because I think I can rewrite it such that I still use that. So if I change this to the integral from 0 to 1 of x over root 4 minus x squared plus, I'm just going to say 3. I'm going to factor out the 3 and do 1 over root 4 minus x squared dx, because then that second one I recognize now as arcsine, where it's the a squared minus the u squared, all that junk. If you don't remember, take a look at those rules. It's in the front page of your book. Don't know if I can get to it quickly enough. Let's see. Let's do it. Calculus. Right. So the very first page, here's my first page. There's the very next page. So the first page that you open to in your book has all of those formulas and everything. That would be very useful for you to know. This stuff is kind of the pre-cal stuff that is useful to know, but not super duper uber important, other than my unit circle and my angle formulas, my identities. So I guess, yeah, kind of all that's important, but not as much of it, but mainly the top half of that. Well, let's get back into our note. So let's see, now I'm going to use my u in this first part, but I'm going to change it up just a little bit because I really want negative 1/2 du equals x dx, such that my x dx will substitute with that du. I'm going to leave my bounds off of it, and I will change them back from 0 to 1 after I do my u substitution. Oh, and I lost my bounds there. There they are. So this is going to be, I'm going to do negative 1/2 the integral of 1 over root u, so u to the negative 1/2 du, plus 3 arcsine of x over 2. And this is now bounded from 0 to 1. And again, notice I left off my bounds on purpose here. I'm going to add them back in. There's 2 things you can do. You can change your bounds using this and make it go from what? 4 minus 0 is 4, 4 minus 1 is 3. You can do 4 to 3. And that would be correct. But since I'm going to have to evaluate this part from 0 to 1, I'm just going to leave this in terms of, I'm going to leave my bounds off. And when I substitute it back in, I'll make the substitution for u, and then I'll throw in 0 and 1 to everything all together, so that way I don't have 2 different bounds. But really, any way you want to do it, it doesn't really matter. So let's see. If I leave my bounds off to do what I'm saying I was going to do, this would be negative 1/2, and then this would be u to the 1/2, so times 2, 2u to the 1/2, plus 3 arcsine of x over 2. Evaluate 0 to 1. So now that u is 4 minus x squared, and this will make positive, or not positive, 2 divided by 2 will make 1. So I have negative root eu, which is 4 minus x squared, plus 3 arcsine of x over 2, all bounded from 0 to 1. Because now when I throw in that 0, arc sine of 0 is 0, and I will just have minus 2 with that 4 minus x squared. So let's throw in 1. So I have negative root 4 minus 1 plus 3 arc sine of 1/2. Arc sine of 1/2 is pi over 6. And then minus a negative root 4. Right, because it's minus 0, and arc sine of 0 is 0. So this will be 2 minus root 3 plus pi over 2 when I simplify everything. Okay, on to our next one. Whew. Tangent squared of 2x. So if I let u be 2x, that won't really do anything for me, because I'll still have that tangent squared. And there's no derivative that I can think of that would be tangent squared. So let's see, the derivative of secant is secant tangent. The derivative of tangent is secant squared. But what if I let this be secant squared of 2x minus 1 dx? All right, so then what that allows me to do is, since the derivative of tangent is secant squared, then this is tangent squared of 2x. And in order to get that 2 out of being in the front, I have to do 1/2 minus x plus c. Yeah. Right, and since it's an indefinite integral, I need to have that plus c for that value of that constant. Notice in the last one we evaluated it, so I did not have to have that plus c. But that's really it. All I had to do was change how it looks, and then it becomes a much easier problem to solve. The 1/2 here, that is coming from u substitution. If you're not comfortable with it, you can write this as your own separate integral, or as its own separate integral, right? The integral of secant squared 2x dx minus the integral of dx. And I could let u be 2x, then du is 2 dx, and then that's where that 1/2 is coming from. But I need you guys to also start getting comfortable with coming up with this without having to write out that u substitution. If you throw in the 2x, sorry, if I take the derivative of this with my chain rule, then that will take care of the 2 out front. So that's it. That's really all there is to it. All right. Okay. Last one down here. So this is one, especially in particular, that changing how it looks is going to kind of change the whole deal. And we're going to pull a trick that it's kind of weird, but it'll make sense once you see it, how it'll work out for us. So as is, there's nothing I can really do. But if I kind of, like I said, change how it looks, and if I multiply the numerator and denominator by e to the negative x, what that will do for me is that will make this integral become e to the negative x over e to the negative x plus 1. Because now, if I let u be e to the negative x plus 1, then du is negative e to the negative x dx. And I can multiply over that negative. So the negative du is e to the x. So there's my e to the x up top. So this becomes negative integral of 1 over u du. Hopefully remember 1 over u is natural log. So negative ln, absolute value, e to the negative x plus 1 plus c. And that's it. That's all I'm going to leave this as. I'm not going to worry about splitting that up. You can if you want to, but it's no big deal. I would just leave it like that. All right, that's really all I got for you guys today. It's really a lot of time for you guys to work through your homework and kind of get back in the swing of things after the break. And let me know what questions you can have for me. All right, I'll talk to y'all soon. Bye-bye!